What is client-side global server load balancing? Client-side global server load balancing, in short GSLB, is an improved version of the traditional server-side GSLB. The client-side load balancer can use a composite DNS metric to provide the client important information about the servers available to him. This information allows the client himself, rather than a traditional remote GSLB server, to make the final decision which server, represented by IP address in a DNS response, is best for him. How does client-side global server load balancing work? Most client-side load balancers use legacy round-robin, weighted round-robin, and random methods. These methods are adequate and have been proven to work, but they do not take into account some of the important parameters in the load balancing process. To achieve the best possible results, modern and advanced client-side global server load balancers use a new and dynamic server selection process with three crucial parameters that are supplied to the client via the standard DNS infrastructure. Topological network distance between the client and the server, measured by the client as a round-trip time value for all IP addresses. Service response time of the server. And current server load, CPU and/or memory load. Why are these three parameters used? Each client has a unique network distance to each particular server. The response time of the service changes over time. Server load is not constant. How does the client decide which server is optimal? The client calculates the composite DNS metric for each server based on the measured and delivered server parameters like service response time and server load and decides for himself which server is optimal for him. During the measurements, the availability of the servers is checked by the client and the network distance is precisely determined. Therefore, the client can always select the server that is available and optimal for him. What are the advantages of client-side global server load balancing? Optimal server selection process by using measured network distance between client and servers, and not approximated with geolocation. Instant failover through real-time server availability checks. No single point of failure. No need for apps to perform an additional DNS lookup. Layer 7 independence that provides clients with better DDoS protection, improved security, and user privacy. Lower total cost of ownership by reducing the need for server load balancers and optimizing server utilization.